Hello everyone, so today we'll be continuing with the function chapter, and today we'll be discussing about storage class specifiers. So what is a storage class specifier? A storage class specifier means how the variables are actually stored during runtime. So during runtime, how the variables are stored, that we shall see. So storage class defines two characteristics of variables. So this is very important. The first one is the lifetime, second one is the visibility. So lifetime means lifetime of a variable is the length of time the variable has to retain a particular value. So we have already discussed about this, but we have not used the term lifetime, nor have we used the term storage class specifier, right? But we already know that a variable stores the data temporarily, and we have already seen discussed in the function chapter that about the local variable and the global variables, right? So we saw that the value is stored in the variable as long as that it stays in that particular function block, or as long as that loop exists, or as long as the function body is accessed. Now once it goes out of that body, the lifetime of the variable ceases to exist, it is destroyed. So that is what is meant by the lifetime of a variable, right? The length of time the variable gets to retain a particular value. That means the variable stores uh, the value only for a particular lifetime. So now visibility. So visibility refers to the scope of a variable, which part of the program can access the variable. Like I've said, if you have not watched the videos for the scope of variables, please go and check that video. Okay, so from there you will understand what is the term visibility. Now why is storage class necessary? Now when a variable is properly defined by its lifetime and visibility, the program uses memory more efficiently, it executes faster and becomes less error prone. So this reduces the complexity of larger build programs. Alright? Now, types of storage class specifiers. So C++ defines four types of modifiers. If you we have already talked about these modifiers. You can refer to data types where we use the modifiers like long, uh, signed, unsigned, right? Along with the built-in data types. So here also similar to that, we use these storage class specifier modifiers, okay, along with the data types. So that affects how a variable is stored. So they are auto, extern, register, and static. So this is used along with the variable, similarly as we use the data type. So the first one we shall see is auto. So now by default all the variables that are declared as auto. So which means to declare automatic variable. So if the storage class is not specified, then it is assumed to be auto. Yeah. So the when we're talking about storage class, remember that we're talking about the lifetime and then the visibility. All right. So based on that, those two characteristics, we are talking about this storage class. Okay. So by default, if the storage class will not be specified, that is the lifetime and the visibility, then it is assumed to be auto. Or here is an example. Here we are declaring int a. So this tells the compiler that variable a is of integer type. So here if we write here auto int a, okay, both the declarations are the same. That means even if we don't write this keyword auto, okay, in here by default the variables are declared as auto. Okay. Now some features of auto are which is similar to a variable. It is stored in memory. Okay. So if the type is not initialized when declaring variable, that is like if you don't mention this when when declaring a variable, the initial value is unpredictable, which is known as garbage value. That means if you're not assigning a value to a variable, okay, and then so we shall see a program on that later on, okay, then a garbage value, a random value based on that data type will be assigned, right? It is local visible to the function block where the variable is declared. If declared outside all function, it is visible to all the function. So that through this we are discussing about where it's mentioning about what is local and what is global, right? So if it is declared outside all function means a global variable. So it retains its value till the control remains in the block where the variable was declared. Once the control moves out of the block, the value is destroyed. So that is talking about the visibility mode, that is the scope, which is similar to this local and global, right? So now a program to demonstrate auto storage class specification. So here you can see that two variables are declared. One is initialized, that is b is assigned the value 20, a is simply declared but it is not initialized, right? So now cout value of a is, you can see here that the variable a is written. So now for in the second line value of b is b, right? So now the value which is stored in variable b, the means like that will be displayed on the monitor screen, that is value of b is 20. But in the case of a, no value has been assigned, right? No value has been assigned. But since the coutput stream is forcing the compiler to the compiler is forcing the coutput stream to display what is in this variable a. So what will happen is that a will display garbage values, that is a random integer value, because the variable a is declared as integer, right? So a random integer value will be displayed on the output screen, which is this. So the actual value of a is not this, but it is a random value, because the actual value of a you have not assigned any value. But if suppose you have here assigned a equals to suppose like 30, then cout will display what is stored in variable a, that is 30, right? So we do not want this garbage value, right? So so by default, okay, or by auto, okay, a value is displayed, since the coutput stream has to display something that is stored in the variable a, right? So by default auto, okay, a random integer value will be displayed on the monitor screen. Now suppose next time you run this program, okay, the variable a may display another random integer value, not this particular same integer value. All right. Now the second one is register. So by declaring a variable as register type, the compiler is able to access the variable as fast as possible. We have already seen in the starting of the unit the word register, right? So for fast access. So similarly like that, okay, when we use it with a variable, then we are able to access the variable values faster. So this can be used when the variable needs to be accessed frequently. So whenever we want a certain variable to be accessed a lot, okay, faster, then what happens is that the variable is stored directly in cache memory. All right. So we don't though it is we use this, okay, rarely do we use this. Now extern. So the modifier extern is used when a large program is split into smaller tasks and stored in different files. That means a large complex program, let's say you have 30-40 pages of a program, right? What you do is that you split the program into smaller programs. It which means that you create different files of program. In function chapter you have seen that in that same program you are splitting the program into, say, like smaller programs, right? Like I've given you an example on that function programs, right? So where you split the programs into 2 or 3 modules, right? Now in this case, when we have to use this extern, a large program, it can be split up into smaller tasks or smaller modules or programs, but it is stored in different files, not in the same .cpp, but in different file. So like cpp1 file 1.cpp, file 2.cpp, file 3.cpp. Suppose like calculator, addition you store it in different file, subtraction you store it in different file, multiplication in different file, and division in different file. So if you are storing all of these in different files, how will you be able to access? Because the compiler can run only one program at a time, right? So how will you be able to access from one file to another file? jump from one file or connect all the 4 different files together. So that is by using this extern. Okay, so the linking between 2 or more files is done by using extern and global variables. Okay, since a global variable is declared outside all functions, right? So that variable, and a variable is used to store data, right? So by that, it can carry, using declaring a global variable, it can carry the data from one file to another file. Okay, so the scope of extern variable is global. So when we declare the variable global variable as extern, okay, which means declared outside all functions. However, if function is written in separate program file, then the variable has to be declared again as extern, right? So to tell the compiler that the variable is defined in another file, so that means uh, using the global variable we can access the other variables in the different files. Okay, so we shall see a program on that using extern. So program to demonstrate extern storage class. So now this is let's say that this is one part of the program. Okay, this is one part of the program and this is another part of the program. So this program is written in one file, that is, let's say, file1.cpp. Okay, and this program is written in another file, that is file2.cpp. Okay, so in file1.cpp, at the beginning of the program here, you are declaring a variable and initializing the value 10. So you're assigning the value 10 to this variable. Now it is written above the header file. So that means this is a global variable, because a global variable is written outside all functions, not inside the main, not inside this, but outside of the main function, outside of other function definitions. So this is a global variable. That means it can be accessible by the main function or by any other functions defined in the program. Okay, so now here, after this iostream.h, here it is mentioned here, hashtag include file2.cpp within these double quotes, right? So this means that to this tells the preprocessor to link this file, to include this file, a separate file to refer from this file. Okay, because in this file2.cpp, the remaining part of the program is written here, right? This is one part of the program, half of the program, and the other half of the program is written in this file2.cpp. So using this preprocessor directive, okay, it tells to uh, search for this file and include this file2.cpp from the include directory. Okay, so now the program starts with void example. So this is a function prototype. So this is the return type. That means this function does not return any value. And then this function name is example. It accepts no parameter. It does not pass any arguments, right? So now in the main function, a simple cout statement is written here. That is cout global variable a value in main is, right? So this will display the global variable value a, which is in this part of the program. So now after that gets displayed, that is global variable of global variable a value in main is 10. So a stores the value 10, right? So that will be displayed. Okay, now after that statement, we have the next line statement is the calling function. So the calling function, as you know, is that it is the main function invokes this calling function, and this calling function, what it will do is that it will call the call function, the function definition. So the function definition is written in another part of the program, right? So that is why this hashtag include file2.cpp is written here. Okay, so that it will contact this other file. All right, so in the other file 2.cpp, what we have done is, since the variable is initialized here, you can see that no values are assigned to this variable, right? So since the input value is here, and yes, in the main function it has been displayed once, but now we want to pass this value 10 from this variable a, that of this variable a to this part of the program, right? So for that purpose, another global variable of extern using this keyword extern is declared. Okay, So using this keyword extend, the same variable int a is declared. Okay, now what happens is this is global variable because it's written outside of the function definition. So when this calling function uh, is invoked, it will call this function void example and execute this function body. So here it will execute global variable a value in example function. That means in here this function is a. So now that value will be passed to here, right? So if you just write here int a, okay, int a, that value will not be passed to this variable a, but because here you wrote this keyword extern, okay, so the value which is stored in this global variable a can be passed and stored in this variable a, and it will be displayed. Right, so this is how you use the extern keyword, okay, to let's say to communicate from one part of the program to another program. So you can see that this is one part of the program, this another part of the program. So you can just imagine that this is a large program which is split up into 2 or 3 programs, right? Now static, the fourth one is static. The static modifier causes a global or local variable to retain its value throughout the life of a program. Now we know that a variable will retain its value as long as the block is executed, right? But the variable value can also change depending on the program logic, right? Now, but using the static keyword, you can retain the value or in that variable for a particular period of time. Okay, so now thus the contents of a static variables are preserved between function calls, unlike normal variable which gets initialized every time a block is called or entered. So every time in a normal variable, every time a block is called by a function call, or you enter the loop, okay, the variable gets initialized. That means the variable starts again. If you remember the for loop, I equals to 0, every time it enters from the inner block to from the outer block to inner block, the inner loop gets initialized again to 0, right? So if we don't want that, okay, we declare the variable as static. So why? Because the static variable initializes only once when a block is first entered. Okay, so for more better understanding, here is a program to demonstrate static storage class. So here you have a function prototype declared outside of the main. Always the function prototype will be declared outside of the main. So void example, right? So now in the main function, you have declared the variable, a normal variable int a. So this is a normal variable declared. Okay, so now the for loop gets executed. So for I equals to 0, I is less than 10, I plus plus. So initialization, you test the condition, right? And then you can increment or decrement. Then the body of the loop, right? So first, second, third. So now in the for loop, you have the calling function written. So this calling function, so as long as this for loop is true, as long as 0 is less than 10 or I is less than 10, okay, this calling function will be called again and again. So that's why the contents of a static variables are preserved between function calls, okay, unlike normal variables which gets initialized every time a call every time a block is called. So here you can see that this for loop gets this for loop, as long as this condition is true, the calling function will call this part of the program, the call function, the function definition, again and again. That means it will call for 10 times. So this calling function will be executed 10 times, will be invoked 10 times, and this function definition body will be executed 10 times. Okay, so now here the keyword static is used here. So int j equals to 0. Now what happens? Now normally if you don't use this keyword static here, okay, and then let's say that this static word is not here, you just say int j equals to 0. Now j will get incremented, that is j equals to 0 plus 1. Plus plus signifies that it gets incremented by 1, so that means j equals to 0 plus 1. See out j is, so j will display the value 1, right? Then after that this function definition returns back to the calling function, and then since this is the since this is in the inside the body of the for loop, the next step is after 1, 2 and 3 the increment will take place. So I will get incremented by 1, 0 plus 1, 1, 1 is less than 10. Again the body of the loop gets a for loop gets executed, and then the calling function will be invoked again, and then it will call this call function again. Then what will happen is that if this keyword is not there, j will again start from 0, and then j will get incremented by 1, and then see out j is 1. So the output value you will get 1 1 1 1 1 1 10 times. Okay, j will the output of j will be you get 1 1 1. What if you want to get a series, right? 1 2 3 4 like that, right? So what happened, you use the keyword static for that. So now when this calling function calls this call function, since the keyword static is written here, okay, j will retain that previous value that it was assigned. So here in j equals to 0, right? So now j equals to j plus 0 plus 1 1. So j value becomes 1. So this is a postfix operator, right? So now after that j will be displayed. See out j is 1. So now 1 will be stored in this variable j. Again after that it comes back to the calling function, okay, and then I gets incremented. 1 is less than 10. Again in the body of the for loop the calling function gets invoked. It calls this call function, and now when it executes the body of this function definition, okay, since the keyword static is written, j will not again initialize to 0, but j will retain that previous value, that is 1. Okay, clear? So that is the use of the keyword static. Okay, so it will retain that previous value that was stored, that is 1, and then j will get incremented. 1 plus 1 2. So see out j is 2. Then again it comes back to the calling function, and then it increments. 2 is less than 10. The body of the for loop, the calling function gets invoked. It calls this call function again. Here static in j value was what? 2, right? So 2 is stored in the variable j because of this keyword static. So j will get incremented. 2 plus 1 3. Then j will get displayed. So when it comes again, j value will be 3, not 0. Okay, so this is how you use the static keyword. Okay, so type this program, run this program, okay, and see the difference between when you use this keyword and when you do not use this keyword. Okay, you can also use this in other programs also, and check out the result that you get. Okay, so go through all of these topics for this storage class specifier. Okay, try to understand each and every topic on that. Okay, and if you have any doubts on this, you can ask. All right.